thinking about coolant automation. I'm Bill Burkey, president of Skimmers. Mike Avery from Benteler, process engineer. Mike, take it away.
Mike Avery, process engineer in Benteler Automotive in Holland, Michigan. A little bit about our company. We do a lot for automotive, from steel tubing to aluminum extrusions and forming. Basically touch around in everything and all aspects of engineering for those. What I do, I model, design, and launch new products for the automotive industry. Look at all aspects of production, start from start to finish, and continuous improvement and implementation of state-of-the-art technologies and processes. One of our processes, and it was a very old and outdated one, was manually adding coolant to our 20 CNCs by means of a proportioning pump and basically just water lines. That created a lot of downtime due to just actually footwork going back and forth between the machines, and I thought that there was something that we could potentially do with that. We had to let them do all the manually checking the bricks readings, refractometer all the time, and there was no way to keep all people on the same page on how it was supposed to work. So a minor thing is, or sometimes it's a major, coolant plays a vital role in machining processes. We need to keep on top of maintenance plans, PMs, and coolant tank cleanliness. Hours of manual labor is involved in, and everyone needs to know the coolant variables such as mixing ratios, concentrations, and foaming degradation. All of that leads to bad parts, bad machining, excessive burns. How do we make our 20 plus machinists and operators all understand each of those to keep up while running parts? So we always had a problem. We were either wasting too much coolant or not having enough. One causes foaming, bad parts smell, and it's not very good for the environment. And the other one is excessive consumption. All of those are very bad. The coolant cost became a big issue with us, and we were tasked with figuring out things to do. So the average cost of a 320 gallon tote of coolant is $9,200. And at the time we were going through 2 totes a month, which equaled up to a cost of $220,000 a year. So I thought, what if we could reduce that cost and reduce indirect labor and be more profitable and invest in automation? For this, we had to approach management with data and tracking that supported and validated our findings that coolant is not only necessary, but also rewarding. We were challenged to investigate and contact other businesses that potentially have something similar to what we thought and our vision showed that we needed, and schedule benchmarking trips to these facilities. We made a list of KPIs and LOPs from benchmarking trips to collectively find the system and program that would work best for our needs and demands. Our decision was the Dazzle 2 coolant automation system. It utilizes a precision mixing algorithm that automatically mixes neat coolant and water to the precise targets to make up concentration for each machine sump. We can set each sump to its own specific levels and concentration for bricks levels. Why Dazzle out of all the other systems that we looked at? It's easy scalable to cater to each individual need. I myself have came up with many options that I needed added and quick to respond to get those implemented for me. Proper coolant to water ratio, creating sump bricks readings based on set values. We change parts daily, so we want to keep our things up to spec for each individual tool, and this system allows us to do that. Worry-free sump levels to keep machines running. Big deal there. People spending a lot of time walking around with machines down, and when you're walking, you're stopping and you're talking to people, we can eliminate all of that. Remote off-site control. If they have a problem with the machine, I can turn it off with an app on my phone or on your laptop or however way you want to manage it with a click of a button. They also have years of cutting fluid knowledge. And one of my favorite items about the Dazzle system is the outstanding and timely customer service. Our process, we had to get management approval to move forwards and contact Skimmers, stopping in to address and review our needs. Zebra Skimmers supplied us a single machine test on our needs for a free trial. As a team, we reviewed our findings and we report these findings for a final approval. Implementation of Dazzle Coolant management system to the rest of the machines. These are a few pictures of our machine and our system. As you can see, we got a lot of automation going on there and new stuff implemented, I like to say monthly. Simple to manage. All readings feed into one software system. You can see all your sumps right there on the screen and know exactly where the readings are when somebody asks if there's an issue. Minimal time invested for training. Make it very simple and easy to use, and it's like plug and play. All machines are at the exact measurements. Return on investment. This one was our biggest issue at Benteler Automotive. Tracking and recording coolant per machine. Preventative maintenance with new data. Indirect labor reduction, which was calculated and a factor in our needed 1 year return on investment. So our stats, 190,200 gallons of coolant Dazzle has pumped. We have 20 machines currently that run from the Dazzle tube. This is an estimation of 5,000 plus trips saved manually to fill the machines. One of the main reasons for our reduction is we were tasked to eliminate 2 CNC tech for the plant. We achieved that with $130K per year labor head reduction by reducing those 2 techs, which allowed us to have $130K more reinvested into new technologies. Looking at automation to implement compliance for lights out manufacturing, reducing labor costs, and strategic planning. Automating this type of coolant distribution is an investment that has paid off, moving us forward in the manufacturing industry. If you have any questions, I'd be willing and able to answer. Any questions?
Yes. You were talking about set valves. So that means that I just want to imagine how you put every single drum, or it is an independent coolant system, or it is a main unit supplying all the machines, or how?
Yeah, I can take this. So it's a centralized system.
It's a centralized.
It's a central system. So from the central system, there's a makeup line to each of the sumps under management.
Okay, and that central system used to be there before.
No, that is the Dazzle system that we built.
Okay.
So
you just have to control one tank, correct?
One unit, right?
Exactly.
And the total coolant sits next or close to that unit. So we bring in coolant, water, and mix that to bring each of the target sumps up to its bricks target.
Okay, so the only container or tank that you are reading is the main one.
Oh, no. We're reading from every
every single machine.
So we're bringing samples back from that continuously from each of the sumps under management. And it goes through a process refractometer. That reading is stored in the database. And then when that sump needs to be filled, we will fill it to bring that sump back up to its target concentration.
And all that is automatic.
It's all automated, yes.
Oh, so imagine having a tap that needs more coolant to it than just an end mill cutting through. We have to have extra lube on the tap so we can keep that one higher than the machine next to it that doesn't run the tap. Therefore, that's how we're doing this coolant savings.
Okay.
We can demand more to one machine, less to this one, somewhere in between on the next one, or we can keep them all flip-flopping around
Okay.
to keep, obviously, the minimum amount to get the job done.
Okay, I see. And with this system, if there is any way to measure the pH level?
So in the recent system, we added a pH meter. We can do that. So bringing the samples back to each of the sumps, we can run that through a pH meter and include that data along with the bricks meter.
So we mainly we are able to control the concentration.
The bricks
The
concentration.
reading from the
Yes.
refractometer.
Yeah. I will say bricks is a little bit more difficult because a sump can have, as you're adding more coolant to the existing sump, the pH benefits of that coolant might degrade over time. So it's unclear really how to bring that sump back up to its pH. Well, I would say that we also have odor control tablets that are a great way to bring that. If the sump is acidic, low pH, use odor control tablets to rebalance that. I think that's probably the best way.
Yes.
pH is very difficult, and the sensors are very difficult to manage as well.
Okay. And another question: what is the minimum quantity of machines that we need in order to have this system work?
4. So with the newer systems, we can start with 4 and work up to the 20. So when we talk about 20 as being the limit, that comes from my experience with ISO 2015 and risk mitigation. You don't want all the eggs in one basket, as they say. You want to spread that risk. If a machine goes down and the whole company has to go back and manually filling, how does that work out?
It doesn't work out very well.
Right.
I'm the one that has to manually fill.
Okay.
Right. So
So we can say about 4 as minimum, 20 as max.
yes.
Okay.
So
Or you can get multiple systems. If you have 40 machines, you can do 2 Dazzle systems.
To this system. Okay.
and the way most machine shops are now, they're kind of in cells anyway. So you can dedicate
And the
Dazzle
4-block
system to
regions.
each cell.
Okay. And can I ask what kind of soluble you are reading? It is a soluble, a semi, or a synthetic?
We use, I like to call it Rain-X. It runs really smooth. It doesn't stick to any surfaces. Everything rolls off. So Bill would be more experienced to answer that question because some people use the Castrol.
Right.
We use a place called Qualichem.
Okay.
There's a plug for that right there. We found that at that time, due to our needs, we couldn't use oil. So we had to get away from the Castrol, which is what he was usually using on previous systems. We had to come up with something for us for our part washing. So we went to this, and it really works well. Other than that, the other stuff we had was gummy. And it was fouling the refractometers.
Yes. Okay.
We try to remain coolant agnostic, but I will say any synthetic coolants are extremely aggressive to different types of material. So if someone has a synthetic coolant, fully synthetic, you have to look at that very carefully, and the systems will have to be built to accommodate those coolants.
Okay. And if there is a limitation regarding the viscosity of the product, because there are some products like carbon compounds that could be with a high viscosity. So, and we also have to add the correct concentration. So, if there is a limit in the viscosity, or
So the way that we mix the coolant is we have used peristaltic pumps, and we can also use diaphragm pumps. So that circumvents that viscosity issue. So we see the viscosity issues all the time with our Venturi mixers, proportioning pumps. Those have to be sized correctly for like a Qualichem extreme pump. Those can be 800 SUS. Those are pretty thick. So you really have to look very carefully at how you're going to mix those with proportioning pumps and Venturi mixers. Whereas we're doing a totally different type of technology to get those into the mix.
okay. And how many months it takes this project? I mean, since you start to see the system with Zebra until you were No,
I believe it was a 10-month build for them,
10 months. Okay.
if I remember correctly. And we started the journey about a year. And then in the 2-month time frame, we had made up our mind after traveling and doing the investigation that that's the route we wanted to go. So from us start to finish, it might not have been a 10-month build time for them. It took us that long to get all of our paperwork, proving to management that behind the scenes, something simple as a coolant is actually needed
Yes.
to get it to them.
Okay.
And this was quite a few years ago. I think the build time is better now. And I don't remember exactly what our time frame was, to be honest. But I know it was in, we looked at it in April, and it was started, and we had it installed the following April. Some of that's on our end,
Yeah.
but that's the process for us.
All right.
And typically for us, the build time is between 3 and 4 months. So these are not cookie cutter machines. They're not crimping off an assembly line. We like to go out and look at the shop, see what the need is, and then custom build a machine for the particular need. Some competitors have a machine you could just pull off like a proportioning pump and say, okay, you can run these machines. We're very skill averse. We try to be as much as we can, and try to minimize fluids overhead. So the makeup lines are 1/2-inch lines that go to each of the sumps from the main unit, and they're evacuated every time you send a shot to that sump.
Okay.
Part of our installation process is to calibrate that. The only fluids overhead are the 1/4-inch sampling lines, input and then a return to the sump. So having fluids overhead can be a touchy business. And also, if you have mechanisms in the ceiling, it can take some time to get to those. So how long does it take for you to find a lift to get to something in the
Hours. And we have our fluids above head. That is the way we ran ours. And if I could do it over again, we would not run them above. Everything would be well and quick to damage.
If you have valving that's attached to a system overhead, and some valving goes bad, that means if you're a one-to-many, that means all those many sumps connected to that are gonna be deprived of fluid. So that means manually filling it.
And we're going to go back to that. Since I eliminated jobs, that makes me be the manual filler. And I would not bring this in if I didn't believe that it kept me from manually filling.
Okay.
Because
Okay.
Yeah, so we have another question.
Oh, yes. So, looking at some of your competitors, I was curious to see that you use data on a dashboard. I'm just curious what Mike thinks about that, if it's been helpful, if it's
as
something
far
he
as
uses.
when we started the process, shopping the Dazzle versus other companies, is that what you're asking?
Yes, yeah. I mean,
What did it for us was the customer service, the availability. We were dealing strictly with Bill at the time. We've had other people. Not so quick to respond to our questions. Many trips for many hours to come up and work with us. I mean, we were at a point where you were looking to throw in the hat. It was, and I said, no, we're too far into this process right now. We sat down in a room and we came up with solutions, and PO was issued.
but you've had no issues with the Dazzle dashboard control system on your
Nope.
computer?
Nope. I like the simplicity of it. I like being able to call it up anywhere I'm at on the phone. That they call me and say, you know, things do happen. Nothing's in a perfect world. If something does malfunction with the phone, I can shut that one off. The other 19 keep going. That's another handy item. Some of the we added a lot of things we have added, some extra things. I just for peace of mind wanted it just to be an expensive proportioning pump. If a valve goes bad, which they do, it's a mechanical device, I can set everything to fail all at the same to buy me some time until I can get the proper parts. I asked Bill, they implemented all of that, and that is a go now. I call it my panic, excuse me, I call it my panic button. If I am out of town on the weekend and something breaks and they say something's bad, I can hit that and everything flips right over on a hit of a switch and everything keeps going. Might be a little bit high for that machine, but keeps me spending time with the family on the weekend rather than going into work to chase down a machine that I'm not even sure if we have any parts for it at the time.
So that is one of the benefits as well, as you mentioned with data. Our system is software-based, so we can change it and adapt it to the customer's needs. So if you have a special type of requirement, we can build that directly into the software.
Bill knows. I'm always calling him and asking him to do something new. Can we do something different? I'm trying to make it easier on myself and easier on the people, so I don't have to manage it. And for some reason, either likes it when we get it or he doesn't think it's going to work, and we go on to a different route that works even better.
It is a collaborative, so when you do buy a system, a Dazzle system, it's like you get Zebra. You do. Yeah. It's not, we're going to sell you a system and then we're going to walk away. And, we're there with you for the journey.
It's 100% the customer service that got us to where we are. If I didn't have the help, we could probably already dropped it in the ocean as a boat anchor.
Have there been any pain points?
There has been some speed bumps. I have asked for items that probably weren't exactly completed properly at the time of leaving. We have all came back and they have all been alleviated within a short amount of time. They came up and they do a lot of traveling. Can't get them. It's functional. It's not exactly where I want it. I express that. Everything gets paid and taken care of in the very shortest time as possible.
Okay, so the customer service is.
That's the whole thing for me is all customer service. But other than that, any pain points, it gets called to me at 7 o'clock in the morning, 3 o'clock in the afternoon, and we resolve them. He tells me which way to go, and I learn on the fly.
Good to know. Thank you.
The frequency to clean the tanks increased or it is less now that you have this system?
So cleaning the tanks isn't really a contributor for the machine for my facility. Bill might be able to talk about another facility. We run at 110%. We don't have the actual downtime, and we don't allow ourselves the downtime to actually clean out the swarf and the chips and stuff out of the little thing. Our main focus is keeping the machines running, so we do as much as we can on our end to do that. This helps that. We are not a clean environment, but it's clean enough with parts washers to get everything done and taken care of.
As I heard from an engineer at Rolls-Royce, if your spindle's not turning, you're not earning. So they're counting that, and so I don't think that this necessarily can keep a tank clean. It keeps the coolant topped up and at concentration, which means the coolant's doing its job. So you're getting the biocides, you're getting the lubricity. So the coolant is actually able to do its job, as opposed to being too lean or too rich.
Even with a dirty tank, they can still sample the coolant, bring it in, and push it back in and keep it full.
It really seems like the type of milling that's being done determines how dirty that sump can be. You know, the types of chips that, and the accessories, if there's chip conveyors, it really depends. Yeah, that's a tough one.
I mean, the sky's the limit for things you can convert and do and a million different things. It's just a matter of if it's all going to work or not.
So an interesting side take. So because this system is configurable and we can change the software, we recently had a customer Hall, they have a crab chip spinner. So they're milling special steel. They're sending all the chips out to the crab, spinning the chips. All the coolant, old coolant is sitting outside. They're bringing that in now to a centrifuge. They're spinning the coolant clean. We're now taking that into the Dazzle system. So say it's roughly 12%. We're mixing it back down to roughly 3%. And that's where a pH meter is also. And then sending it out overhead lines to 120 sumps. So this is, I think this is the direction people will be going in the future, trying to recycle because those costs of the coolant are
Yeah.
crazy.
And
We
also
are-
the waste of water.
Yes,
We are saving a lot of water if
Yeah.
we keep the systems running like that.
right.
Even with our cost savings, I know we can even get it more with the recycling, and we will be talking about that shortly as well. If we still waste a lot, and we lose it in a dirty environment. So we don't have any air conditioning, and we don't even have heat in our building, so that they run the door open. So in the summertime, we lose a lot of water due to evaporation.
Yeah.
So every time it fills, it tries not to pull as much coolant, but it still takes some of the living where it stayed in there.
Yeah.
So that's we have to come up with different things for that. Cooling fans at level take care of some of that,
Yeah.
and the coolant recycling will be a big one for us.
Yes. It will be very interesting to know how many gallons we are saving with this system because a lot of people don't imagine how much water we use in a CNC machine.
It's hard to gauge the water. What we can gauge, which is on billable materials and consumable coolant, we cut ours 50%. So the coolant's 640 gallons a month. We're down to 300 gallons every 2 months now. So just the cost savings alone on that was part of our return on investment was enough.
Yeah.
Getting rid of or eliminating our CNC techs and centers for those that were just designated for machine maintenance are now gone.
So this is an ecological solution as well.
It is as well, right? Sustainability. Yeah.
And it's a behind the scene thing. They don't see it, so you have to actually force your management and your owners to see that this matters.
Oh yeah.
And that was the hardest part of the journey. Is that it's just cool to throw water in it. They don't know anything. All of a sudden now we see it and show it to them, and the numbers actually matter when it comes down at the end. Then it becomes, okay, now it's the wow factor.
Yes.
And then it never stops. Now they want you to do the next step to eliminate another $10,000 coat to coolant.
The invisible cost.
Yep.
It is, yeah.
It is. It's
Yeah.
indirect labor and indirect cost, and that's how they look at it. They bring that up in our meetings monthly. Why do we spend so much on coolant? Well, do you want to see where we were 3 years ago?
Yeah.
No, we want to see where we are right now. What's the next step to go? That it's a never-ending scenario.
Right. Very good.
So, one of my concerns, listening to this is, what are people doing, that were previously working on these machines? Are they just losing their jobs? Or are they being, are you able to move them to different positions so that they're better using their time? I mean, it sounds like it's just kind of a waste for them to be doing this, where they could be doing something much more helpful in the company.
So this is one area of our company, our 20 CNC machines. We also have assembly cells. We also have robotic machining cells that run off of MQL, oil-based type of coolant. We have an extrusion line. So when I say we eliminated that job, we didn't eliminate, we just eliminated it from that department and replaced them into a different, into a different area of our building.
Great.
That was in the same pace.
Okay.
So they were Tech 1s, we put them in a Tech 1 spot in our extrusion line or our assembly line, which they still had to oversee their duties. Those things don't use.
So
I mean, no.
all around, it's more efficient then.
Yes. Yep. So we weren't out to cut labor heads, ropes, and make them eliminate their jobs. We didn't want to just get them out of this department, because that's the department that I worry about. Place them somewhere else, and they won't be needed to stand there and hit a button for the 5 machines we had, or tote the 5-gallon buckets that weigh 30 pounds. They can do, walk 25 feet, or you walk 150 feet multiple times an hour to keep up in the summertime with the operations.
Great to hear.
So that bucket brigade, we installed a system in Halliburton in Oklahoma. They had one machine that was consuming 200 gallons of fluids a day, makeup fluid. 200. And it was an uneven floor. The operator had to wheel this coolant couch 60 gallons over that many times a day, breaking his back. And that was probably 300 feet he was dragging that. That's a lot of work, and that's a lot of time away from the machine.
Oh, yeah.
So it's a huge efficiency for them.
Okay.
Yeah, the operator's there watching parts and making parts and not worrying about the coolant.
We decided to go in that our operators and our setters know nothing, and if I can take that away from them and alleviate everybody's thing that just takes care of it, they can focus on something else in a different area. So the better it gets, the more people I move, and we add other automations, like we're going to a robot install right now, because we were able to get rid of that labor head and move them away. We could have the robot, we only need one person now. So that's the direction that this actually led to, just for them wanting me to save $10,000 a year in cooling costs. We had way above and beyond the Call of Duty on that. So something simple as a fluid.
Yes.
Not even a part, not even a cutting tool.
No. Yeah.
But coolant is a tool, and it's not often seen as a tool.
Yes.
Yep.
Absolutely.
One thing Mike touched on that I want to discuss a little bit is operators using refractometers to take readings. It's kind of a fraud deal. However, when we developed the Dazzle system, we thought we want to go full automation. That's why we incorporated process refractometer. That takes the operator out of the equation. We built the technology, refractometers clean, but if that doesn't always work, they're easy enough to clean. They pop off, you wipe them, you put them back on, you're back in business. It's a very simple process. But also there are some companies that don't want to do that. I mean, that comes with a cost. So we also have a Dazzle 2E and we built an app that operators can input their own refractometer readings on their phone. So it's a progressive web app. That goes back to a database, to a main system. So instead of having a refractometer, that's the reading we use to mix the coolant to fill that particular cell. So we have it's a progression. So we have the Dazzle 2E and the Dazzle 2. And beyond that is the recycling Dazzle. We don't have a name for that yet. But I see that as a big growth area now, is recycled coolant, just lower cost and saving water.
I can tell you, we probably throw 50 to 60 gallons a day away of coolant in our coolant hoppers. We're still in the process of trying to figure that out. If we can get those to dump into a centralized unit and recycle that and put that back in, that's another savings.
Yeah, what's the cost to get rid of that a month?
To be honest, I don't know, because it goes away in a chip hopper.
It's expensive though, isn't it, for those guys that couldn't get that? It's a hazardous material, so there's additional costs on the back end of it all as well.
Well, I can get these to get them out into another tote, let's say, when it gets empty, or flip flop, keep it going daily to get it back and forth. That would be another huge opportunity to build that into the system.
Okay.
Thank you very much. Thank you.